Everyone. So this is going to be my first talk to CSS this quarter. So what I'm gonna do is it's going to be a mishmash of a lot of things. Um, we're going to talk a little bit about uh, why we should care about cybersecurity, and we are also going to talk about why does it matter specifically for webs. And I specifically chose that topic because I think you guys are having this as a theme for this quarter. You guys discussed some front end, some back end, different stuff for this quarter for the CSS meeting. So I thought that it might be appropriate to talk about this. So without further ado, if you don't know me, my name is Mohammad Husain. I'm a associate professor in the Department of Computer Science. And my specialty is in the field of cybersecurity. I'm also the faculty advisor for your club, in case you didn't know that. And and that's one of the reason I kind of pushed myself to make sure that I show up and I talk to you. Um, and I'm also the faculty advisor for our She Codes Club. How many of you know about the She Codes Club? It's our Women in Computer Science Club that we have in the computer science department. Uh, so I'm really passionate about student clubs. Okay, as you can see that uh, I made that one of my missions, and I believe that student clubs are very important factors in your success for CS career. Okay, and few more CS career advice, and I'm just going to go over that quickly. Um, is These are the 5 things I kind of summarized that I have seen. This is my 5th year in this school. In the last 4 years, I have seen these are the things most of the successful students have done. Okay, they're very well placed either in industry or in the graduate school. Okay, first thing is know your CS academics. Okay, go to advising center, talk to the advisors. We have some amazing advisors in the advising center. How many of you know about the advising center? How many of you have visited advising center at least once? Okay, uh, they're there to help you. Okay, in terms of preparing your career, when to take what classes, so on and so forth. And also talk to a faculty advisor. And that's something I'm going to point out in the second point, that you need to be proactive. Okay, don't assume that if you just complete a computer science bachelor degree with a 4.0 GPA is going to get you a nice job or a nice graduate school. Okay, you have to be beyond what regular students do. Okay, so and that can be something like a programming project, something that Brian was talking about. um, as a part of the club, you can do a project, and you can kind of showcase it on either GitHub, make a link available on your resume, and make sure that you kind of talk about this to your employer. Okay, or you can also participate in research project. I'm also going to talk about a couple of the research projects that are available in the cybersecurity domain. Be active in the club. Okay, but make sure you manage your time well. Sometimes I see that you end up joining 4 or 5 clubs and then you don't manage your time well. So you're having fun, that's good. You're building leadership skill, but you need to know it's a balance. Okay, so the clubs are there to help you to build your leadership skill, build your communication skill, so on and so forth. But it doesn't replace your academic performance. Okay, GPA is not the only factor of your only measure of your success, but when the employers are looking at your file, many times they filter it out by GPA. So if you have very low GPA, something below 3, okay, even if you have other extracurricular things, you're probably going to be left out. Okay, so make sure that you manage your time well. Okay, you identify what are your responsibilities in the club, and then you kind of um, uh, follow that schedule for yourself. And be helpful. Okay, so when you go to your um, junior or senior year, mentor people inside the department, okay, or participate in outreach activities where we go to the high schools and teach them computer science, okay, and this helps you a lot. These things are also a very important thing on your resume. Be prepared. Decide early. Okay, by your junior year, you should know whether you're going for a grad school or job. Okay, by your junior year. Okay, many times, even in the junior year, I see students coming to my office hour and telling me I don't know what I want to do. Okay, and the answer for that question lies in this one. Okay, if you start some project early on, okay, you will know what you like, what you don't like. Okay, you don't know whether you like it or not like it if you didn't try it. Okay, make sense? So you have to try it. So this point number one, okay, all your 4 years you have to do it. Personal programming research project, as soon as you finish something like 240, you should start it. Go and talk to a faculty member, ask them what kind of projects that they have, okay, or you might have taken a class with them. Go to their officer and talk to them. Do you have something for me? Okay, it doesn't have to be a research project. It can be independent study. Okay, you want to study virtual reality, okay, so you can take up that project. And in the computer science department, we have these courses called 461 and 462, where you can get the elective credits for doing programming project or research. Okay, so just talk to the faculty member. So if you start this thing early, this one will be easier for you. Okay, by the time you do your project, your faculty advisor is probably going to tell you that you are a research material or you are a industry material. Okay, it's pretty straightforward from a faculty advisor perspective. But these are the things I have seen in the students who ended up going to like big PhD programs, ended up going to top notch industry. Okay, so make sure that you kind of use this throughout your CS career. I know you guys are different standing in your CS career, but uh, most important thing is finding a personal project or research on top of your CS academic career. Okay. Why is it not working? Okay. All right. Okay. So this is something that I profess as a cybersecurity faculty member, is that I don't expect all of you guys to be a cybersecurity expert, okay? But I expect all of you to be cyber smart, okay? Whenever you are programming, whenever you're writing a software, whether it's a desktop application, whether it's a web application, whether it's a mobile app, whether you're writing a program to control some network protocols, you are aware of cybersecurity. That's the most important part. And that's why you will see that in the computer science department, I do not prefer to have a cybersecurity tag, because cybersecurity is inbuilt in computer science. If you do computer science in a right way, you are doing cybersecurity. You get hacked if you don't apply computer science in a proper way. The very fundamentals we teach in computer science, okay? It's just the fact that you be aware, okay, what you're trying to do. And I just give one of these examples, okay? So this whole Internet of Things domain we have contributed as a computer science, okay? We attached devices from left and right to this whole Internet of Things domain, but then this happened, okay? So we attached this cameras to internet, but we attached this without understanding that some other people might take a peek at it. Okay, so there was no authentication, no password protection for many of the products that came in. Okay, we also had this. Okay, we converted cars to smart cars. The cars are now being controlled with embedded software. Okay, the embedded software inside your car, this actually controls anything from your brake to your engine to your infotainment to your tire pressure to everything. Okay, and this was a live hack that was shown where the hackers from 10 miles apart, they hacked into this Jeep car, and then they demonstrated what they can do. Okay, um, and so then we also had this incident where we connected our refrigerators to internet. Okay, so we wrote a small tiny embedded software where your refrigerator can tweet to you telling you the temperature of the milk in the fridge. Okay, but there was no authentication. Okay, so the hackers were using it to launch a denial of service attack against other customers. Okay, and then we also had this, the police body cams that came pre-installed inside the software, inside the firmware. They had some virus installed in it, pre-installed in it when it was supplied to the police. Okay, so I just want you to think for a second. Okay, think for a second that who has the responsibility to make it secure. Okay, you don't expect somebody else to secure your software. Okay, you build in the security, you follow the security procedures, and security procedures are nothing beyond your computer science practice. Okay, you need to think the security of your software personally. Okay, how many of you would like the fact that you went to a pizza store, bought a pizza, and someone came and slapped on your face and took the pizza out of your hand? You hate it, right? It's the same thing. Your software is your baby. Okay, if someone is making a fool out of you by hacking into your software, you should take it personally. Okay, so from the very beginning, when you are even doing the UML diagram, okay, you should think about security, how someone can abuse your software. So far, all of us thought that when we write a software, it's going to be used by angels in heaven. Okay, so they are not going to try anything malicious. Okay, so you need to change the mindset. Okay, if you think that your software is going to run on Satan's computer, okay, who can do anything they want with the software, okay, you will have that practice that is known as defensive programming. Okay, you don't hard code passwords inside your software. You think it's dumb? Just search internet. How many people still hard code passwords inside their software? Hard code license keys inside their software. And how easy it is to find out. If you use a decompiler, okay, you can figure out in the assembly code where the license key is. Okay, there's so many. Just search YouTube. Okay, it's so easy to find it out, and many people are still doing it. Okay, so a little bit of your discretion can change the world. As I said, I don't expect all of you to be cybersecurity expert and do vulnerability analysis and start doing like hotshot things in cybersecurity. But all of you either are going to be software engineer, mobile app engineer, web app engineer, or you'll be network engineer. Just have this extra cyber antenna up on the back of your mind. Whenever you are writing a software, think about it. Okay, if you're working in JPL, you're dealing with data. okay, that you might be getting from satellites. Okay, you are writing an API, okay, that will deal with the software, and if you don't care, okay, there might be cases that some other people can use the weakness in your software to hack into the satellite. That's how things happen, because we don't target um, the strongest link. We target the weakest link. Okay. So a small effort can save a lot of time, energy, and money, and also some jail time. And this is, I'm really serious. There are cyber laws. Okay. If you intentionally divulge information, okay, if you intentionally disclose information for someone, there can be jail time, there can be fines, okay. And very soon you will see that as a software engineer you will need insurances, okay, like doctors, okay, because if your software is running someone's car, that car got hacked, someone gets killed, who pays for it? Okay, the car insurance is going to be blaming the embedded software company. Okay, okay, you'll not only lose your job, but there will be strong consequences for this, trust me. Okay, last year DHS has summoned all the car companies to patch their software. DHS hired consultants to pen test different cars embedded software and asked them to fix it. Okay, because the cyber is no more too far away from our real life. It's with the Internet of Things, it's very close to our life. Okay, with the medical devices and everything getting connected to internet, and someone can hack into it, they can kill a person. So I'm serious about jail time. Okay, there will be consequences. Okay, and especially from this point onwards, the things that we have seen in our election, okay, the amount of hacks that happened. Okay, so people are going to be exercising more and more these laws. So be careful when you're writing in software if you don't protect your customers' information. Okay, and because of your software, if the credit card information gone out, the credit card company is no more going to take the blame. They are going to dump it on the software company, and it will come down to you, either in the form of losing your job or paying the fine. Okay, so let's talk a little bit about the Poly Psych Lab that we have in the Department of Computer Science. This is our cybersecurity lab, and we have different grants and funding in the lab from National Science Foundation, Department of Homeland Security, National Security Agency, Intel, Boeing, uh, Northrop Grumman, Sandia National Lab, and all of them, support different kind of projects, as well as we also have a cybersecurity scholarship in the department um, that provides you scholarship to work for federal agencies after your graduation. Um, and then these are few projects that we have in the lab. We have got this funding from National Science Foundation to build the next generation of Android OS. And the goal is that you will be able to access the complete Android device over a browser. So we are building that interface where you can access an Android device from the browser, and it can help people to do research and experiment on the Android devices remotely. We also have this project where we are trying to use brainwaves to authenticate people. So the first part was we are trying to find out the proof of concept, whether it is possible to use something like this brainwave scanner and then convert it to data on the computer and then use that data to identify a person. And right now we are building a comprehensive library that you can use any brainwave set and then capture the data. We also have this cyber physical system security setup where we are trying to build this toolkit using different type of sensors and Android devices, Raspberry Pi devices. And both of these two projects are supported by Intel, and then we are doing a lot of vulnerability analysis of this different Internet of Things devices. So, if you're interested in any of these projects, you can talk to me later on. All right, so for the sake of time, let's talk a little bit about the web security or insecurity. And I think, right now you should be able to understand this architecture a little bit better if you have participated in uh, the CSS talk so far. As you can see on the client side, okay, you can use a browser or command line software to access a web. And then on the server side, we have all this different technology that are being used. And many times on the background, the server is also talking to a database, okay? And so among all different types of software, when we're talking about desktop software, mobile applications, and web applications, web applications are probably the hardest to secure, okay? Because there are so many parties involved. You have an open base of users. So when you're writing a desktop software, many times you can, if it is a proprietary software, your user base who's going to use it. But if you're writing a web application, it's public. Anybody can use it. Anybody can try anything to it, okay? So the top 3 vulnerabilities for the web is cross-site request forgery, cross-site scripting, and code injection, okay? So don't look at the actual hard definition that I put in there, okay? So let's try to understand the facts, okay? When you log into your Facebook, okay, once you logged in, do you enter your password every time that you try to get in? No, right? So your computer is storing some information on your computer somehow to identify your account to the Facebook server, okay? So that information is accessible by your browser, okay? So you logged into Facebook, and then on your browser, you stored a small piece of information, okay? That's known as the authentication token, okay? So anytime a request generates from your computer, Facebook server knows that it's coming from you, so it gives it access to your account, okay? However, it is also possible for somebody else, okay, to create a link, okay, that will fake a request from your side, okay? So let me show you guys a quick example, and I think probably from the time perspective, we're just going to talk about this one, okay? So this is a social network, small social network software, and this is specially set up for this demonstration. So the idea is Bob is stalking Alice. Alice doesn't want to add Bob to her friend list, okay? So Bob keeps sending requests to Alice to add Bob to her list, and Alice keeps rejecting it. So what Bob can do is Bob can create this thing called cross-site request forgery, okay, where Bob can create this malicious site. Do you see anything in this website? No. But if I look at the source of this website, what you see is this is the website. This is the social network website. Okay, so I'm skipping a lot of steps. This is a virtual machine. On this virtual machine, I have a social networking software up, and I have two users, Alice and Bob. Okay, and this CSRF Lab elgg.com. This is a social networking site. And on the background of this site, uh, although you don't see anything, okay, uh, okay, CS. Okay, so this one was the website that I was showing you, and it has hidden this request inside its source. Okay, so I can go to uh, which one was that? Okay, so if I have clicked on that link, you can see that I have gone to Alice's friend and I have added Bob as a friend. Okay, so what that other site did was it actually faked a request. Okay, when Alice clicked on it, it went to the social networking website as if Alice had made that request. Okay, so let me redo it again. Sierra, okay. So the scenario is Bob sends this request to Alice in email, and Alice, as soon as Alice clicks on this link, Bob will be added to Alice's list. So let's remove from Alice's account, let's remove Bob as a friend. Okay, and then you can see there is no friend here. Okay, and then as soon as Alice clicks on this website again, Bob is getting added. Okay, and this is one of the most severe attacks that can happen right now. Okay, so I can launch this attack against you. I can send you a link. Okay, as you can see that if you click on the csrflabattacker.com, there is nothing on that website. I just took an image tag and I included that friend add request there. So unless you're looking at the source, you don't know what's going on. Okay, so that's why everyone tells you that don't click on a link if you don't know who is sending it to. Okay, in the background they can do a lot of things. Okay, okay, so I can essentially send you a link to add a specific search term to your Facebook account. Okay, if you're logged into your Facebook account and if you click on my link, I can add the fact that you have searched for some anti-government thing on your Facebook and you can get arrested. Okay, if I can craft it well and if I know which bank you have account with, and if you click on my link, I can start making changes to your bank account. Okay, it does take some trial and error. You can look up YouTube. There is a demonstration of the Facebook. I cannot do it live here, and since Tom is recording, but so all the things that I have shown here, this is completely kosher. This is on virtual machine. This is a fake social network. I just wanted to show you the dynamics of it and how easy it is to do. Okay, and there are many other similar attacks, but this is probably the one I mean, I was playing around with a couple of other websites, like, I don't want to name it, uh, but you will be surprised, like big real estate companies, okay, they have no clue, okay. And the last point of advice is when you use open source libraries, okay, right now most of us don't invent the wheel. We try to use someone else's code snippet, right? Please review the code before you use it, okay? Because you might be pawned because of a bug that you had inside that code, okay? And 80% of the time when we see vulnerabilities on websites is because of one of the libraries that they have used, and many times it's open source, okay? So please do yourself a favor. If you're using a specific method, a specific library from open source community, okay, just search for one more term, known vulnerabilities for this library, okay, on Google. The hacker community is actually very good. If they find vulnerabilities, they post it online. So you will see a link someplace that talks about the vulnerabilities with that library. And please try to use the patch before you include that library in your software. All right. So with that, I'm going to close the talk. We started a little late, but thank you for showing up. My office is Building 8, Room 41. This quarter, I was not as available as I used to be. I just had a baby boy in August. So, but next 2 quarters, I'll be more available. And please stop by and talk about your projects or research, anything. Thank you so much.